Hi, so welcome back to Economies of Scale. This is CC4. We're on page 34 of your booklet, and the last time we spoke through the narrated PowerPoint, we were looking at sources of economies of scale, and we got to the point where we discussed internal and external economies of scale. I mentioned last time round this principle, this container principle, which demonstrates clearly how economies of scale can work. So on page 34, Article C, which looks specifically at internal sources of economies of scale, it looks at the law of increased dimensions, or the container principle. And if you read the article, or the question, if you like, which actually explains this idea of cubic law, and the doubling of height, width, and size of a tanker leads to being able to build proportionately a much bigger container for significantly less cost when you look at the overall amount of material required. So if we take as the example, you can see that we've got a 2 meter by 2 meter container. So the volume is 8 meters, 8 cubic meters. But if we double the size of that to 4 meters by 4 meters by 4 meters, our volume is significantly increased to 64 cubic meters. And if we then look at the reasons why that then effectively causes economies of scale, well, let's just take a look and see. So the small container we mentioned, basically our volume is 8 cubic meters, 2 by 2 by 2. The surface area of steel needed is actually 24 square meters, so that's 2 by 2 times 6. And so the steel required is basically £300 worth of steel, so three square meters at 100 meters per square meter, £100 per square meter. Sorry, so that gives you £300 worth of steel required for an 8 meter cube capacity container. If we take a look at a large container, then the large container, as illustrated on page 34, you would have volume in this case doubled in terms of the overall size. The overall size of the container has doubled in terms of going from 2 meters by 2 meters by 2 meters to 4 meters by 4 meters by 4 meters. So that's going to give you 64 cubic meters of space. The surface area of steel needed in this case is 96 square meters. But in this instance, because we can negotiate a better, the amount of steel required is in this case 1.5 meters squared at 100 meters, £100 per square meter. So that's £150. It's actually 50% cheaper than the smaller container. And the reason for that is because obviously you can gain economies of scale by the amount of steel that you're buying. If we take an extra large container, then if we go 6 by 6 by 6, surface area of steel needed is 216 meters. In this instance, we can take that, and in this case it's even cheaper because of the economies of scale we're able to achieve. And as a result of that, that's the reason why in some cases we do look to go much bigger and can gain economies of scale based on the size of container in this case required. And it's the efficiency really of the buying, and also the size of the container that's being built, that gives you those savings. Okay, so examples of how you might be able to gain from this principle then. Well, obviously things like commercial aircraft, where you're buying significant amounts of a particular resource, that allows you to negotiate better prices. So commercial aircraft like the A380, which I believe is a Boeing, and warehouses as well. The size and scale of warehouses obviously becomes much more efficient in terms of the building of them, when you go much bigger, because you can make significant savings. Okay, let's move on then and take a look at the next section then. So we looked at some examples of internal economies of scale in addition to the container principle. Now we're going to take a look at some questions, some exercises to test what we've covered so far. So if we take a look on page 36, you've got the question that's included in the PowerPoint here. So we've got a range of different outputs for firm A, firm B, firm C, firm D, and firm E, and we've also got their long run average cost. So for each firm, for A to E, we need to give the range of output over which there are economies of scale first, and then diseconomies of scale second, and then the optimum level or range of output, and also the minimum efficient scale of production. Now, we've covered all of those things in the previous presentation, so you might need to take a look at that and your notes to just double check this process. But remember, we're looking for the point at which firm A is achieving economies of scale, then firm B, etc., etc., etc. So I'll give you some time to give that a go. And I suggest you stop the PowerPoint there. Have a go at filling in that table, which is on page 36 in your booklet. And then we'll come back and look at the answers in this instance, okay? So welcome back, and in this case we'll take a look at how this all works out. Okay, so in this instance, remember the principle is that we're trying to find the point at which with economies of scale are being achieved, diseconomies of scale start to happen, what our optimum output might be, and also our minimum efficient scale of production. So remember, effectively, we've got this long run average cost curve where initially we've got a high level of cost, and then it's coming down to the point where we're actually reaching our optimum production point where our long run average cost is at its lowest point and consistently there. And then we've got this diseconomy starting to happen when we've got increasing costs caused by a number of reasons, one including diseconomies of scale. So obviously we can take a look at that, and in this instance we can see that for firm A, we could draw the graph into to make sure that you were understanding that whole process. But in this instance, then, if we take a look at the table, we can see that when we produce at over 3 million, then we have a cost of a long run average cost of 5. Anything below that is going to be slightly higher. Okay, and so as a result of that, the point at which we can start to achieve economies of scale, or the best economies of scale, would be at an output of 3 million units. Okay, because remember, looking at that table, you can see that the outputs, it gives you the units that it's been measured in, and that's in millions of units. You can see that once we get past 6, okay, then between 6 and 7 million units, you can see that we've got an increase in our long run average cost from 5 to 6 pounds. So in that instance, obviously, we've got the scenario that is showing on the graph. Sorry. So if we then take that principle and then apply the same principle to A, B, C, D, and E, you can see that for our economies of scale, where our long run average cost is at its lowest, that is anywhere between so we're gaining economies of scale from 1 million through to 3 million in terms of our overall long run average cost. So our average cost is coming down from £10 per unit for the first million to 8 for the second, and down to 5 for the third. So we're gaining economies of scale as we get up to 3 million units of production. In this instance, for firm B, you can see that actually we get that same principle where our long run average cost is coming down from 1, 2, 3, 4, and 5 million. So you can see that at that point we're actually gaining economies of scale from 1 million all the way through to 5 million units produced. Firm C, where we've got £16 as our average cost for 1 million, 14 for 2 million, and then it starts to go up again. So basically we're gaining economies of scale from 1 million through to 2 million in terms of Firm C. Firm D, you can see that in this instance, actually, we go from 19, 18, 17, 16, 15, 14, 13. So basically, all the way through up to 7 million, which is all that we've got figures for. Firm D is actually achieving economies of scale. So good for them. And then for Firm D, you can see that again, it starts at 20, goes to 17, then to 15, then to 14. So the point at which Firm E starts to or manages to achieve economies of scale, i.e. is lowering its long run average cost, is from 1 million through to 4 million. Let's take a look at diseconomies of scale next, then, where long run average cost is starting to go up. Well, in this instance, for Firm A, it's from between 6 million and 7 million, where we go from 5 to 6. Same applies to Firm B, but in this instance our costs go from 10 to 11, between 6 million and 7 million units produced. Firm C, you can see that really from 2 million, where we've had a fall from 16 to 14, from 1 million to 2 million, then effectively from 2 million through to 7 million, we've got increasing costs. So essentially we've got diseconomies of scale going on there. Firm D doesn't apply, does it? Because we haven't got diseconomies of scale at all. We've got economies of scale all the way through. We've actually improved our long run average cost at every level of production. So that wouldn't apply in this instance. And then finally, again, we've got the same principle where effectively Firm E have gone from 20 to 17 to 15 all the way through to 14 up to 7 million. And so again, we're not showing any diseconomies of scale based on the charts that we've been provided. Okay, so if we then look at the optimum output, that's basically where we've got the long run average cost at its lowest point. So basically, our minimum long run average cost is essentially that point there. Now, in this instance, basically, our optimum output level is basically 3 million through to 6 million for Firm A, because at that point we've got long run average cost at 5 for each of those different levels of production or levels of output. For Firm B, where our lowest long run average cost is £10, that's happening between 5 and 6 million units of production. The minimum long run average cost is basically for Firm C is 2 million, where we've got a long run average cost down to 14. Firm D, again, that long run average cost is the minimum long run average cost is at 7 million, because for each of the previous units we've managed to reduce the long run average cost. And for Firm E, that's 4 million through to 7 million. So from 14 at 4 million all the way through to 14 at 7 million. So our minimum efficient scale of production would be the minimum quantity for achieving minimum long run average cost, sort of shorthand if you like, would be for Firm A would be 3 million. That's the starting point at which we would actually get our lowest long run average cost. For B, that would be 5 million, where we've got the long run average cost down to 10. Firm C, it would be 2 million, where it's 14, and that's the lowest that it gets to. Firm D, it would be 7 million. That again is where we've achieved a low cost, the lowest average cost at 13. And in this instance, Firm E would actually be 4 million, where we've achieved 14 for the first time, which is the cheapest amount that we can produce at, or the cheapest and the lowest level of output that we can produce at 14 in terms of the unit cost. Okay, so a bit long-winded that, but hopefully that then explains in a bit more detail how you can arrive at those figures by just taking a look at, in this case, a table of figures, and it gives you the correct response. Okay, let's have a look at the second question then, where we've got orders for new container ships, and this is to do with the container principle, container capacity, number of containers the ship can carry, and then the orders for new container ships. Okay, so the table shows orders that for new container ships, and by carrying capacity. And what can it be inferred from the data then? The transport of containers by ship has what in this instance? Looking at the number of orders that have been provided for container ships, you can see that in this instance there is a significant difference in terms of the size. So from under 2,000 up to between 2 and 3, nearly 4,000, 4,000 to 5, 6,000, and then 6,000 plus. So it would imply, given that information, that there are significant economies of scale in this instance. Okay, and as a result of that, you're likely to get greater demand for ships as unit costs can be reduced and therefore increased profits. Let's take a look then at the last question before we then move on to look at other parts of economies of scale. So in this instance, we've got a short case study which talks about the Spanish airline Iberia, which merged with the UK airline British Airways. Looks at operating costs. I want you to read through that and see what you can come up with in terms of the question, which asks what economies of scale might IAG enjoy compared to BA, Iberia and Aer Lingus as independent airlines. Okay, so thinking about that, have a read through that, jot a few things down, and then I will stop the presentation, jot a few things down, and then we'll come back and take a look at what some of those economies of scale may well be. Okay, so welcome back. Some of the things that some of the economies of scale that IAG could achieve based on this would include, obviously, technical. We could go for larger aircraft. Could also look at purchasing. You get purchasing economies of scale because fuel and the amount of fuel being bought and the number of aircraft being bought would clearly be more for the combined group than it would be just for IAG in this instance. No, that's a combination. So IAG would actually gain benefits, gain economies of scale over and above the three separate entities that came together to form IAG. Clearly, there are marketing opportunities. You get larger, more effective campaigns. Financial would be another one because as a larger group, they're likely to be able to negotiate cheaper borrowing. And all of those things obviously help to explain some of the advantages of economies of scale as far as IAG is concerned. Okay, so let's take a look then and move on and look at the next section where we're looking at external economies of scale and diseconomies of scale. So in this instance, if we were going to draw that out, so there is some information within page 38 which shows you external economies of scale, where we're talking about falling average cost of production, shown by a downward shift in the long run average cost curve, and that can be based on a number of things that we looked at previously, where we're looking at the growth of an industry within an area which might lead to better local transport networks, lower training costs, research and development facilities in local universities, component suppliers setting up in your area, and also technology, where normally speaking we assume that for the long run average cost that technology remains unchanged, but in the very long run we might find that technologies will change too, and actually add to greater efficiencies. Okay, so if we're talking about economies of scale, that's going to cause a shift in the long run average cost curve of an individual firm, and that's going to obviously go downwards, because if we get those economies of scale, that's going to reduce our average costs, and as a result of that, we're going to, given a particular level of output, the costs are going to be lower because the industry as a whole may have grown. So if we're looking at that in terms of an example and trying to illustrate that, there's our original long run average cost curve. Okay, the long run average cost curve 1. If we start to achieve, and obviously that the point at Q is our minimum efficient scale of production. Okay, so that again for LRAC1 is going to be at Q star or Q asterisk. Okay, now if we get a situation where we get external economies of scale, that's going to lower our long run average cost curve, and it's going to move it down to LRAC2. Now you can see as a result of that, then we're going to get a slight change, because for LRAC2, clearly the costs to produce at that same level as LRAC1 are going to be significantly less. And so in this situation, you can see that we have a reduction in our long run average cost curve caused by external economies of scale. Okay, if we have external diseconomies of scale, and that's something that we'll look at in a bit more detail in a minute, then when the opposite is going to happen, where essentially we're going to get an increase in the long run average cost curve. So external diseconomies of scale are going to cause long run average cost curve, the long run average cost curve to go up. So that's going to be an overall increase. In that situation, clearly, we're going to have at that same level of output at Q, we're going to have significantly higher costs, and also you can see that we're not at the minimum efficient scale either, because this would be at this point here, okay, rather than where we're still getting some fall. So effectively, that is also going to change. So, looking at some sources of internal and external economies of scale then, so this is when we're talking about diseconomies, so costs getting higher. That's basically where we're going to get a rise in the long run average cost of production as a firm expands beyond its optimum size. And there are a number of reasons for that, a number of sources. So internal examples could be loss of control, so your management span is too wide, and as a result of that, one department may not know what another's doing. You might get a sort of silo mentality where different departments simply aren't working together, and that clearly can cause inefficiencies. It can also be an issue in terms of coordination. If you're talking about a multinational company, for instance, where you've got lots and lots of different departments across the world, spread across the world, then that makes it very difficult to coordinate on all sorts of levels. So that can also be an internal example of diseconomies of scale. Could be poor cooperation. You might find that sales aren't working with production, or marketing aren't working well with production, and where we've got maybe some satisficing going on, where certain individuals who are running departments might have their own agenda that might not necessarily lead to overall good cooperation within an organisation. You could have communications difficulties. Could be time zones if you're talking about different parts of the world, if you're a multinational company, but also just working in the same country, but in in far-flung places. Although obviously technology and Teams and video conferencing and Skype, etc., has significantly improved and has obviously been quite heavily stress tested during the pandemic, there are still sometimes communication difficulties which need to be borne in mind. So how can they be avoided? Well, in some cases, if you're thinking about each one of those, each internal example that we've got listed there, if you've got better management of your organisation, then a lot of those things can, they're not necessarily going to disappear, but you can certainly try to address some of those issues. Okay, so it could be improved human resources management, making sure that people know exactly what their roles are, and also making sure that people are clear as to what their expectations are of them in their particular roles. You might be able to introduce performance-related pay schemes where you're encouraging, in this case, organisations will actually, to some degree, link your performance to the level of reward that you're going to get. So that can also work quite well. You could choose to outsource manufacture. One could argue that if you've actually outsourcing manufacture completely, you might be able to get over some of the internal issues, and where you're giving somebody wholesale the responsibility for manufacturing. It becomes another management task, but it's a different management task from maybe an internal management process. Some external examples then that we'd need to consider too, some external diseconomies of scale. Could be where you've got individual firms competing with each other to bid up the price of raw materials and or labour and factor inputs. Clearly, that's going to cause high levels of cost for you as a business. I'm just going to move my picture up there a bit to make it slightly easier for you to read the text that we're going to look at. We might get increased traffic congestion and longer delivery times as a result because of the number of businesses and firms that are working in a particular area, and that sometimes might cause an issue. If it delays you being able to get your product to market, that might be an issue that's going to cause diseconomies of scale. Okay, so those are all the areas that we need to think about as far as economies of scale and diseconomies of scale are concerned. And remember, being able to draw out, and obviously the drawing of economies of scale, diseconomies of scale, the minimum efficient production level are quite easy to understand and get your head around. It's definitely worth making sure that you understand and can demonstrate that when it comes to showing economies of scale. Okay, if you flick to page 41 in your booklet, then there is a research task I'd like you to take a look at. Obviously, it's slightly difficult if you do it in small groups, but I'd like you to undertake some research on one of the following areas. So you've got a range of different areas in the UK that have a specific impact on, in some cases, economies of scale, but also that where there are specialist areas that have been set up in certain parts of the country. And I'd like you to just take a look at one of each of those. Look at the history and the birth of the region, so the impact of the cluster or the hub on firms, including costs, and also maybe government policy. Have the government tried to encourage this principle of hubs being set up? And then obviously I'd like you to relate that to the principle of the how that might bring down at the average cost curve, and certainly the long run average cost curve. Okay, so that's something for you to do as an ongoing task, and obviously that's going to allow you to have some examples where you can actually start to apply that information to certain things. Okay. Okay, the next thing we're going to start to look at then is marginal, average and total revenue. Okay, so we're moving on from economies of scale and starting to look at three very specific and different areas. Now, the areas you're going to need to be able to understand include the following. The difference between marginal, average and total revenue is something that you're going to need to understand and be able to apply. Why the average revenue curve is the firm's demand curve. Now remember, we've really only been talking about long run and different types of cost at the moment. Now obviously when we start to look at profit, we're going to need to look at a number of things, not just long run and short run cost curves, but also revenue curves and the difference between certain marginal curves too. So we're going to need to bring the two together now as we start to demonstrate how different types of market structure work and how different types of organisations within market structures work. Okay. The next thing is the relationship between average and marginal revenue, and some of these terms, marginal revenue, I know we talked briefly about marginal cost and marginal revenue. We're going to be looking at that in quite a bit more detail over the next couple of sessions. The relationship between marginal revenue and total revenue, and how those two things are clearly quite closely related. And you're going to need to be able to calculate marginal, average and total revenue from given data. Now that might sound complicated, it's not actually too difficult, as we'll see. But you also will need to be able to draw and interpret revenue curves. Okay, so we're essentially bringing revenue curves and cost curves together, and hopefully you can see that if you've got revenue curves and cost curves, you should be able to see where and whether a business is making profit, i.e. their total revenue being higher than their total costs. Okay, so that's what we're going to be looking at over the next couple of sessions, as I mentioned. So first and foremost then, let's take a look at what revenue is then. We've talked about this briefly before, but there are a few sort of definitions I just want to make sure that you're clear on before we sort of move forward on this. So first things first then, revenue, basically the income a firm receives from selling its output. So to calculate your total revenue, basically simple principle, selling price of the good or service that you're selling times the number of, or the quantity sold of that particular item. Okay, now when we come to calculate average revenue, we take our total revenue and we divide it by the amount of output. Okay, so obviously our average revenue would be clearly, if you think about total revenue divided by output, that's also going to be your selling price, isn't it, effectively? So so that's something to bear in mind. Marginal revenue then is basically known as MR, is the addition to total revenue from the sale of one more unit of output. Okay, and so the marginal revenue is another way of looking at it, is the change in total revenue divided by the change in output. Okay, now so that's something about revenue, and also the different types of revenue and different ways in which we can calculate revenue, average revenue, marginal revenue, etc. Okay, now to some degree, how's that going to affect, or how is revenue going to be affected by the market structure of a firm? Well, the market structure that firms operate in will clearly have an effect on price and sales revenue when a firm increases the quantity sold. Okay, so in this instance, we need to bear in mind, and we're going to come back and look at market structure in the next booklet, but fundamentally, you need to remember a number of things. Okay, and now clearly we've mentioned that the average revenue and the firm's cost demand curve have a fairly clear connection, and we'll see why that is when we take a look at this diagram that we're going to look at. Okay, so the diagram that we're going to show you in a minute actually looks at demand conditions facing a high street retailer of electrical goods in a particular week. Okay, so in this instance, the firm sets prices of ovens at £500 and has 20 customers who want to buy an oven at that price. So in that situation, the total sales revenue for that organisation would be £10,000. Okay, so basically we got 500 as our selling price, and we got 20 customers who want to buy that particular oven. So £10,000, and our average revenue per oven sold is £500. Okay, so effectively we've taken total revenue and divided it by output, and that gives us our average revenue. That's £500. Okay. However, if we take a look at the scenario where we might reduce the price, if we reduce the price to £300, our oven seller could sell 60 ovens. And in that situation, clearly, we would have total revenue at a higher level of £18,000 and the average revenue being £300. So at each of these levels of sales, the average revenue of the retailer is the same as the price charged. Okay, and this is always going to be the case when the price is charged. The price is the same for all units of output being sold. Now that's not a normal scenario, but if that were the case, that would be the situation. So in those conditions, okay, the demand curve facing the firm is also going to be its average revenue curve, and that obviously makes a reasonable amount of sense, doesn't it? Okay, so let's take a look at what that graph looks like then. In this case, we've got microwave ovens that we're referring to. So we've got the price of microwave ovens. We've got our starting point at 500. We've got our next level at 300, and you can see that at these levels, we've basically got this type of demand going on. Okay, so you can see that at the first point at the price of 500, we basically got 20 customers wanting to buy our goods. At 300, we've got 60. And so effectively, we're showing what we've actually described in words as now our demand curve. So the average revenue and the firm's demand curve basically are one of the same, where, as we said before, the average revenue for the retailer is the same as the price charged, assuming that all the units of output are being sold at that particular price. Okay. So let's take a look at the relationship between average and marginal revenue then. So in this scenario, we normally find that marginal and average cost curves are plotted from the same set of data, and they will always display the following relationship. Okay, so when marginal is greater than the average, so when the marginal revenue is greater than the average is going to rise, isn't it? If you think about it, if the revenue we're generating from one extra unit is higher than the average, which is the one that I've just described, then clearly the average is going to rise. However, if the marginal revenue is less than the average, then the average is going to fall. That sort of makes sense, doesn't it? When the marginal revenue is equal to the average revenue, the average is constant, and so it's neither going to fall or rise. So those are things to bear in mind, and we're going to be looking at how that all works through over the next couple of sessions. The last thing we're going to look at, and I think we're going to stop, is the different types of market structure that we might face. This is something we are going to look at in a little bit more detail over the course of the next couple of sessions. Okay, now effectively market structure can affect a whole range of scenarios. Okay, and we've got, in economics, we look at four and sometimes 5 different types of competition. Okay, and they range from perfect competition, which is described here on the left-hand side of this continuum, through to monopolistic competition, oligopoly, duopoly, and monopoly. And each different set of rules, essentially, for each different type of competitive situation has quite a big impact on the way in which an organisation may be able to work. Now, some of these are quite theoretical, as you'll see. Some of them don't really bear any relation to what actually happens in the real world, but you will need to understand the different types of competition within a market and different types of market structure. Okay, now effectively, if we take a look at our chart here, and this is included on page 43 in your booklet. Effectively, the most competition or the most competitive market would be a perfectly competitive market. Now, we'll come back and look at perfect competition again in quite a bit more detail, but we'll run through what some of the conditions are for a perfectly competitive market. So that is the most competitive position on the left-hand side of our chart, through to monopoly, where effectively we got one firm producing 100% of market output. And so that's going to be the least competitive, because essentially you've only got one market or one organisation providing all of the market's requirements. Okay, so in terms of the way in which average revenue and marginal revenue is calculated, that is obviously going to have an impact in terms of the market structure that we're talking about. Now, if we're talking about a perfectly competitive market, let's start at that point, and then we'll come back and look at some of the other types of market structure at a later stage. Okay, a perfectly competitive market would have, as it lists here, a large number of buyers and sellers. They all have perfect market information, so they know exactly what's going on. They know who's buying what and who's selling what, and they are able to buy and sell as much as they wish at the ruling market price. Okay, so the market price is set. Okay, they're unable to influence the ruling market price, and they have a uniform or homogeneous product, so everybody is selling the same thing, and there are no barriers to entry or exit in the long run. So effectively, the market price is set by the fact that there are so many people all selling the same thing, and able to buy and sell as much as they wish at a particular ruling price. So in that situation, they are what are known as price takers. So they're given a price, they have no influence over that price, and that's what they have to sell at. Okay. Now that is clearly a very different scenario from even oligopoly, where you've got a few independent firms, each needing to take account of rivals' reactions when deciding on their own marketing strategy. And so you've got a level of imperfect competition. You've also got competition in terms of the different types of products and services that different organisations may have, and they are basically very different from perfectly competitive markets. Okay, so that's something we will come back and look at in quite a bit more detail over the course of the next set of information in this booklet, but also when we start to look at CC5, which looks more specifically at this whole area of different types of market structure and how that influences firms' behaviours. Okay, so again, just to reiterate, just to re-summarise, so for a market to be perfectly competitive, there must be certain conditions that market will exhibit. Okay, the first is there's a very large number of buyers and sellers. All buyers and sellers possess perfect information about what's happening in the market, so they're completely well informed and know exactly what's going on. Consumers can buy as much as they wish, and firms can sell as much as they want to at the ruling market price, and that is set in the market as a whole. Individual consumers and suppliers can't affect the ruling market price by their own actions, so they have no influence over that at all. And the products are identical, they're homogeneous, and they are all being provided by the different sellers, but they have no difference. They're not able to differentiate their product at all. And there are no barriers to entry or exit, so that means that there's no major cost or major issue in terms of getting into the market, but also there are no penalties for exiting the market in the long run. So that's something to bear in mind, okay? As I've said before, and I will say it again, probably to the point of exhaustion as far as you guys are concerned, perfectly competitive markets, although they are quite an important theoretical principle to understand both productive and allocative efficient markets, very, very rarely exist. It's almost impossible for them to exist in the markets in which in real life markets. However, they're a very useful concept to be used when we're talking about trying to be the most efficient that we can in terms of allocating scarce resources to infinite needs. Okay, I think we'll stop there. So we'll move on to the next instance to look at the relationship between average and marginal revenue in perfect competition. So once again, thanks for listening, and I'll catch up with you guys soon.